You are sitting at your desk at home, studying anatomy and physiology. Specifically, you're studying osmosis and diffusion. As you're studying, you find that your eyes are getting heavier and heavier. It's harder to keep them open. The last thing you remember is closing your eyes and falling asleep on your book. You suddenly awake, but you're no longer in your house. You're actually piloting a helicopter, which appears to be flying around a beaker that's filled with solution, and when you look around, you see this large cell that's located in the middle of the beaker. You decide to land on the cell, and as you bring the helicopter down, you see on the cell membrane a note. You get out of the helicopter and you pick up the note. It tells you that you've been chosen for a special mission, a mission to study the process of osmosis. As you walk around the cell membrane, you notice that it is selectively permeable. What does that mean? It means that small molecules can diffuse through the membrane and large molecules cannot. You know to carry out this mission, you're going to have to remember the rules of diffusion. What are they? 1. A molecule has to be small enough to diffuse through the membrane. 2. There has to be a concentration gradient, which means there has to be a high concentration of the molecule on one side of the membrane and a low concentration on the other. The third is that diffusion doesn't take any energy. As long as there's a high concentration to a low concentration and the molecule can fit, it will diffuse from one side of the membrane to the other. You also remember that osmosis is just a special term for the diffusion of water, but the same rules of diffusion apply to osmosis. Suddenly, you hear a strange noise, and you look up. You see that a spaceship is dumping large amounts of salt water within the beaker that you're in. Luckily, your special spacesuit is going to protect you, but you start to think, what is going to happen to the cell, since it's now being surrounded or it's in an environment that has a lot of salt? You remember from your anatomy class that in order to determine which way water is going to diffuse, you have to figure out what side of the membrane is hypertonic and which side is hypotonic. You remember that the hypertonic side of the membrane is the one that has more solute or more stuff, which also means it has less water. The hypotonic side of the membrane is the one that has less solute or less stuff, which also means that it has more water. As you now swim around the beaker, you try to determine which side of the membrane is hypertonic and which is hypotonic. You determine that the outside, the environment, the salt water, is hypertonic because it has a lot more stuff and less water. Since the outside of the membrane in this case is hypertonic, that makes the cell hypotonic. So as you sit there and watch, what starts to happen to the cell? Does it get bigger or smaller? As you swim around, you notice that the cell starts to shrivel because the water is moving from the hypotonic side of the membrane to the hypertonic. As you watch the cell get smaller and smaller, you start to worry that your helicopter, your only mode of transportation, is going to get destroyed. But then suddenly you hear a flushing noise, and the seawater, the salt water, is drained out of the beaker. But the cell in the helicopter sits safely at the bottom of the beaker. As suddenly as the flushing stops, you suddenly hear that spaceship above you again. You look up and you notice that it's dumping large amounts of distilled water into the beaker. You now have to rethink what type of environment the cell is in. You know that distilled water is pretty much just water, so it must be the hypotonic side of the membrane because it has very little stuff and a lot of water. That would make the inside of the cell hypertonic. It has a lot of stuff and a very little amount of water. So what do you see start happening to the cell? You see it start to grow as the water diffuses from the hypotonic side into the cell, which is hypertonic. So the cell continues to grow, and as it keeps growing, you start to get nervous because you think the cell is going to burst. But then suddenly, again, you hear a flushing noise, and the distilled water leaves the beaker. This whole flushing thing is starting to make you really nervous, so you run back to your helicopter and you get in. But before you take off, you think to yourself, what kind of environment could I put this cell in that would allow it to stay its normal size? And you remember from class that if you put a cell in an isotonic situation, that it will stay the same size. Remember what isotonic means. It means that both sides of the membrane have the same amount of stuff and the same amount of water, so diffusion or osmosis will not occur. Now that you finally have this whole osmosis thing figured out, you turn on the helicopter and you start to take off and you begin to fly away out of the beaker. But then suddenly in the back of your mind you hear the sound of one of the 92 trains that travels through Vincennes on a daily basis has woken you up. You realize that the whole beaker helicopter thing was a dream, but you're amazed at how much you learned just from that experience. You decide that since you learned so much from that dream, that maybe it's just better to go to sleep, and hopefully you'll have more dreams about physiology. Good night.